and welcome back for Titan 7M. In this project we're going to build this model on your screen here. So let's get started. Alright, so here we have sheet 1, and we got a rather interesting shape here to do. So we're going to be modeling this one a little bit differently than we normally do. But at the end of the day, it's going to use all the same skills that you've learned so far. So let's have a look at how to do this. So to begin, as usual, we're going to save our work in the right spot, and then we will create a new component. So since we already know how to do that, I'm going to fast forward through the rest of this. Be right back. Alright, so now that we're done, we can create our first sketch on the top plane, and we'll just rename our sketch as usual to make things organized. So in this case, we'll call it sheet 1, but for a little bit of extra flair, let's start labeling it basic shape as well. That way we have an idea of what we did on sheet 1. So we'll start with a 2-corner rectangle and drag it out to create a box the shape of our entire thing, and enter our dimensions. So 1.95 by 4.375. Alright, let's dimension our lines to give ourselves the perfect thing. So we'll dimension from the origin to this point, and it is 2.375. The origin to this point, 1.2. Origin to this point, 3.125. And the origin to that point, 0.475. And now it's all constrained in black. Now that we've got everything constrained, let's get the break tool out. What we'll do is we'll break that line there and that line there, just so that we can hit X and make those two lines a construction line, just to make it a little more like the drawing. That looks good. So let's finish our sketch, and we need to extrude this negative 0.75, and then we have our basic shape. The only thing left to do now is fillet the corners. So let's grab the fillet tool. We'll select all 5 corners that need a fillet, and once we've done that, we'll enter the radius of 0.1. And there we go. So all we need now is plug in the last two, there and there, and type in a radius of 0.375. Enter. And that's it. That's the basic shape, all done and dusted. On to the next sheet. So on this sheet we're going to be dealing with a different type of hole. So up till now we've been working with a drilled hole, and now we're going to be dealing with counter bores. So let's talk a little bit about different hole sizes. So on the screen now is a drawing that shows 3 holes from left to right. One is a plain hole. The second middle one is a counter bore, and the third one is a countersink, and we've dealt with countersinks and regular holes already. So on the screen right now, I've put a picture of 2 different fasteners. The one on the left is a socket head cap screw, and the one on the right is a flat countersunk cap screw. And as you can see by the shape, the one on the left will fit into the counter bore because of the shape of the head and the shape of the hole, and the countersunk one will fit into the countersink hole because of the shape of the head. So when we look at sheet 2 here, we can see a tells us that we need to put 4.25 through holes in the part, as well as 4 times countersink with a diameter of 0.380 and a depth of 0.315 from the surface. So those are the dimensions we need to make the counterbore. It's also asking us to put a chamfer with a diameter of 0.4 on the part as well, on each hole when it's done. So since we've modeled plain holes and we have modeled countersunk holes, let's learn how to do counterbores. So let's go. Alright, so let's get points placed for our holes. Create a new sketch on the top plane, and we're going to click on Create Point and drop 4 points down roughly where they should be, and then we'll fix them with constraints and turn them into holes. So there's our points. Let's go up to the horizontal and vertical constraint. Let's make these bottom ones all in line with each other vertically and horizontally. So there we go. So next we're going to click D for dimension and click the origin and our first point, type in 0.375, enter. Origin to our second point, 1.75, enter. Origin to the third point, type in 4, enter. We'll go the other direction now. Origin to the first point, type in 1.575, enter. And we'll go origin to the last point and type in 0.375, enter. Alright, so now that we're done that, hit finish sketch, and we'll rename this sketch while we're here to keep organized. Sheet 2/holes should be good. Enter. Alright, let's start the hole command, and we'll select the 4 points, and then we'll go through the settings for the holes. As always, don't worry about that, how it looks. We'll fix that in a second. So we'll go over. We need to click on counterbore because we're going to be doing a counterbore as discussed earlier, and hole type is simple and drill point is fine. It doesn't matter, we're drilling all the way through. So let's keep moving on. As for the settings, as the depth is going to be all the way through, we'll go to extents and select all. We'll set the counterbore diameter now, and that's going to be 0.380. We'll set the depth of the counterbore at 0.315. And the diameter of the through hole, 0.25. Hit OK. And there is our holes. On looking at the hole, you can see the counterbore that goes down a little ways for the head of the bolt to go into, or the cap screw, and then the through hole is smaller and it goes all the way through. Alright, so let's put the chamfers on these 4 holes, which is the last thing to do. The print calls for a chamfer diameter of 0.4, so we're going to achieve that by selecting the 4 holes, the edges there, and we're going to type in a chamfer diameter of 0.01 and hit enter, and that'll give us a chamfer diameter of 4, because if you remember, the diameter of the countersink is 0.38, and then a 10 thou chamfer on each side, or all the way around, is going to create that 0.4 chamfer. Let's move on to sheet 3. So with sheet 3 up in front of you, we can see that we need to create a cutout on either side of the part. That cutout is symmetrical, so what we do to one side we can do to the other. And it's a bit funky looking, but with some radiuses and some lines, we can create the geometry as seen. So let's crack on with that. So we'll start by creating a new sketch on the top plane of the part. We'll rename it Sheet 3/cutout and then hit enter. We'll begin to create the rough shape by using the offset command. So we can hit O for offset, click on and drag it out, or type in, and we'll type in 0.125, which is the dimension on the print. We'll now use the line command for adding in the extra geometry. We'll just roughly sketch it in there and use constraints to fix it up. So we'll start by making the bottom line collinear with the rest of the part geometry. So click collinear, click the line, click that line, and it snaps down into place, turns black. We'll use the perpendicular constraint to make that perpendicular and that one perpendicular. It might give an error, but so the last thing we'll do is use the dimensioning tool to place those lines that are blue perfectly and constrained. So D for dimension. So we'll click the origin, this point here, and type in 3.75, enter. Origin, this line, type in 0.625, and now it's all black and constrained, which is good. Well, next we'll trim out those two lines there using the trim command. And now we can finish our sketch, and we can finish up the geometry with an extrusion. So we'll click extrude, we'll click that part and that part of the geometry and extrude it -0.25, enter, cuts it away. And now we can finish up with the fillet command, put our radiuses in. So we'll start with this one right at the point since it's different, 0.025, enter. Looks good. We'll move with the fillet command and we'll do this one, this one, this one, all 5 of these at 0.1, enter. It looks good. And the last thing we're going to do is the 2 radiuses right here. So click there and type in 0.275, enter. And now our part is all done except for copying it over to the other side. And we'll do that using a mid-plane and mirror it. So we'll do construct, mid-plane. We'll click the top of the part and we'll roll it over, click the bottom of the part, and it creates a plane right dead set in the middle, which is good. We can use that to mirror our work. So we'll create mirror. It asks us to select the objects. We'll select it by going into our timeline and select our extrusion and all of our fillets, holding down the Control or Shift key. And then mirror plane we select, and we will go and click on the mirror plane and hit OK. And it makes a duplicate on the other side. And then we don't have to redo everything. We can turn off the construction plane and it looks pretty good. As always, we do have to break the edges with the chamfer tool, so let's do that right now. Chamfer, we'll click all these edges, so that one, that one, that one, and that one, and we'll type in 0.01. Don't forget the holes on the other side. So 0.01, enter, and that's it. Titan 7M is done. Good job. and we'll see you on the next one.